The topic for today is making t the subject of formula using completing the square method. I think that's the only way you can actually make t the subject of formula. Most likely at this level, maybe in advanced math, you might get to understand or know other methods or another method of doing it. Now, first, you have to understand that this is a quadratic equation, and your t in cases of a simple quadratic equation stands for s, and since it's squared, it owns the square, and so this is the coefficient of the squared, this coefficient of the t without the squared, or the x without the squared, as we may call it. We're going with quadratic equation, and the s stands for the constant. Now, we said that the first step says take out the constant. The constant is already on the other side of the equal to sign. And for us to solve this question better, we can rearrange it without, in case as people might understand, I think, oh, we're moving this and this to the other side of equal to sign. Side it changes the sign. Yeah, that's right. Then you're moving this, changes the sign. But in cases like this, where you have it, you can just rearrange without changing the sign, because you eventually get the same thing. So for sake of easy understanding, I will have solved it the way I'm saying it, but for you to easily understand, you can write as half a t squared plus ut equals s. Now the first step says divide through by the coefficient of x squared, and this case is t squared. So and this can first be written as a times 1 as a over 2 t squared plus ut equals x. Dividing through by this means can also mean multiplying by. It's like saying the reason why we're dividing through by the value of the coefficient of t squared is to make sure the coefficient of t squared is 1. And we can also multiply by what they call the multiplicative inverse. So the multiplicative inverse is like taking this up to numerator and this below, so it will now be 2 over a. 2 over a is a cancels a, then 2 cancels 2, then you left to 1. That's the reason why you do that. So we'll just in short form multiply every term in the equation by 2 over a, rather than divide by a over 2, still the same thing. So you have a over 2 times 2 over a t squared plus ut times 2 over a equals x times 2 over a. This cancels this out, you'll be left with, this will be t squared plus 2 times u is 2u over a, then the t equals 2 times x, that's 2x over a. Next line says multiply the coefficient of t by half, then square it. So on the next page, that's what we'll be doing. You have t squared plus 2u over a t equals 2s over a, and the coefficient of t is 2u over a times half, then square it. That's 2u times 1, 2u. 2 times a is 2a, and then we got all squared. We can cancel out the 2's and be left with u over a all squared. Then the law says, or the rule says, you add it to both sides as the coefficient of t after multiplying by half and squaring it, multiply it to both sides. So you'll be on this side, you have t squared plus 2uat plus u over a all squared equals 2sa plus u squared. So you saw u over a all squared. Now on this side, you have to get rid of this by joining these two together. So it will be t plus u over a all squared equals 2s over a plus, you can open this bracket, u squared over a squared. You should do that by now. Then on this side, you find the LCM. The LCM is a squared. A squared in a, if you left it on a times 2s is 2as. A squared in a squared, that's 1. 1 times u squared is u squared equals t plus u over a all squared. The next line says find the square, do a square root of both sides. So you have square root of t plus u over a all squared equals square root of 2as plus u squared over a squared. The square root cancels the square, you'll be left with t plus u over a equals, on this side you can find, the separate, you can give them the separate square root. That's square root of 2as plus u squared over square root of a squared. T plus u over a equals plus or minus square root of 2as plus u squared over square root of a squared is a. The next step says take out this to the other side. So it will be t equals minus u over a plus or minus square root of, now you can rearrange this if you like and take this here and take this here. Since they are linked by plus, you can rearrange if you want. You can leave it as u squared plus 2as over a. Then you find the LCM. The LCM is a. A in a1, 1 times minus u is minus u, plus or minus a in a1, a times square root of u squared plus 2as is square root of u squared plus 2as. And this is actually the result, final answer of making t the subject of formula.